Welcome back, students. So we're going to answer some of the every third question in transformation geometry, and we'll do the example. So what is transformation geometry? Well, three or four, maybe four transformations. So it's an umbrella term for different types of movement about the plane. And they're called rigid transformations because there is no getting bigger or getting smaller or getting stretched or distorted in any way. Okay, so they're rigid transformations. Okay, so what's the first one? The first, or what we call it, the first one is a translation. So the simplest thing you can move is a point. You take a point, and we might move it 4 places to the right and 1 place up, and it'll end up in here. So this is called the image, and this is called the object, and we'd often just use a prime to say where it's gone to. Okay, now that could have been this could have been part of a triangle, in which case we would end up with a resulting triangle over here, and so on. So not only points and line segments, but indeed more complicated, but always simple objects. So typically triangles, circles, squares, are what's going to get moved around. Okay, that's one transformation. Another transformation then is just this reflection. You can reflect in the origin. So if we have a point, my axis isn't great now for this. Let's actually align with the grid. Okay, so we'll go with an X and a Y. Best I can. X-axis and a Y-axis. Okay, so now if I was to be out here at 3, 2. We'll assume a scale is 1 to 1. There's my scale. Then where's this going under central symmetry in the origin? Okay, so where it's going is it's basically heading to the origin and following on by the same amount the other to the far side. Okay, and if this is D, this here is D prime. Okay, and look, by doing the examples, we'll make it very clear. That's the second type. As another type is axial symmetry in the x-axis, and indeed axial symmetry in the y-axis. So if I was to do this axial symmetry in the x-axis, it would end up down here. We would end up at 3 minus 2. Now we could put some maths on this sort of mathsy stuff on things here as well. So like as in we can define what they do. I'll show you what I mean now. So this would be back 3 up 2. So if we take the point xy, then we can say we can talk about axial symmetry in x acting upon xy. So it's a function in geometry. So it acts upon xy, and it creates, well, the x value stays the same and the y value changes. Similarly, the axial symmetry in the y-axis of xy, this is the general statement of what it does, will turn it into minus xy. And central symmetry in the origin acting on xy will turn it into minus x minus y. Okay, so it's nice to know these things, important to know them. Now, if you take a vector or a translation that is, say, add 5, add 2, say, or we might even give it a general, say PQ, then do we have a thing for translation? So the translation using this particular vector, call it translation 1. Translation 1 will take in an xy as the inputs, and it'll output x plus p, y plus q. Got it? Okay, very theoretical and everything, but you'll find the questions quite handy. Okay, sure, look, I'll do them all, and you can pick out the ones you were set for homework yourselves if you want to follow along. But you should be following along with all this stuff. So describe in translation what maps the blue shape to the red shape. Hold your horses now, I read that way too quick. Let's enjoy the reading of this. Describe the translation. Okay, there's a keyword. Yellow highlighter? Don't think so. Let's just go with underlining. Describe the translation that maps the blue shape onto the red shape. Okay, I get it. in each of the following. Use words such as right, left, up, and down. Okay, if you insist. So, what's the translation going from blue to red? Move right. How many places? Now, be careful we don't mix up our points. To the far side. 1, 2, 3, 4, 5. Okay, you see to the near side. 1, 2, 3, 4, 5. Okay, 5 right. And the definition then would be like this. 1, 2, 3, 4. 4 right. 1, 2, 3 to the right. Way better to be doing it this way, by the way. 3, 1 is the translation, but they want me saying 3 to the right, 1 up. Fine. Okay, 1 to the right, 3 up. Look, it's too slow. We're going to go this way. Now, obviously, that's not a lattice point, meaning it's not a grid point. So we take a lattice point that we can kind of keep track of. 1, 2, 1, 2, 3. This is a grid point. Back, 1, up, 1, 2, 3, 4. Minus 1, 4. Now, 1 left, 4 up. For someone who doesn't understand coordinate geometry. Okay, describe fully the translation that maps shape L to K. Okay, L to K. So it is a translation. Any one corner will do us. 1, 2, 3, 4, 5. 5, 3. Add 5, add 3. Shape J to L. Just want to tidy that up there now. I want you to have a clean sheet here while we look at this. J to L. Okay, so by the way, I might use the coordinates now. From minus 5 up to 6 is 11. And that was to the right, and down, I think we can count boxes 1. Okay. M onto L. 1, 2, 3, 4. 4, 5. Etc. You get it. Okay. Question 3. Construct the image of the letter T under the given translation AB. So we're heading this amount. Now, when it comes to constructing it, you should be using, you can use your set square and a ruler to kind of slide this line down and have it go that way. So, but I can do quite a decent job here now in a kind of alternative way. Okay, I can actually measure the angle of that. Which is, I think we did a pretty good job first time round is 19. Okay, so I'm going to take every relevant corner and I'm going to draw down a working line here. Okay, I might have been slightly offset there, but it'll do. There's going to be something going on in here. Here. And then just here. So you only take critical corners where things happen, and then you can just join them up straight afterwards. Okay, now I need to sort of measure, which is a bit of a stretch for me here, but I think I'll use this inch. So I'm counting there on the inches, and I'm counting 1, 2, 3. You'll be using your compass here, 4. Okay, so I'd be counting out 4 of them. But look, I'm a bit, let's just say, once you've moved 1, then you'll know that this guy here is straight up, and then we're going straight over here. Okay, you'll obviously be using your compass for the length, and your direction will be done using maybe this and a ruler, and you'll slide this along just like I did there. Okay, and so this would be, this is the object, this is the image. Draw the triangle twice and construct its image under BC. So what happens there is everything in the object goes along that So basically this corner turns into this corner, and the line, it'll go out here like this and up here like this and back here like this. And then this will be B prime, C prime, A prime. You're given a lot of construction to do here. We might do that one in class. And draw the triangle twice and construct its image under from A to C. Okay, so that's A to C there. So that's our movement. So this point will head off here. This point will head off here. And this point, this A gets mapped to C. We end up with this triangle. A to B is a square it is, so A prime, B prime, C prime, D prime. 6 under D to B, so we're heading this way. Come out here. Of course, if they ask you to construct, now that's an awful lot of work, the constructing, with your construction kit, which is fun and we can do it. 6, excuse me, excuse me. So we have a rectangle. What's the image of A under from D to C? From D to C, what's the image of A, B? Right, can you see it? From D to C goes like that, so A goes to B. What's the image of line segment AB under translation BC? Oh, there's a new thing I didn't tell you about. So that's the one way of saying the translation, and you have that in your log tables under vectors. We'll have a look at that some other day. Do I have my log tables? I'm going to mess up the video now if I go looking for it. Am I? Let's have a quick look. File, give me open recent, or is it here? We might be lucky. I'm looking for my fully bookmarked log tables. Okay, and I'm looking at my bookmarks now, which are here. And I'm looking for maybe vectors. Geometry notation. Let's come in here with geometry. There it is. Vector A to B. See here? Vector from A to B. So a vector and a translation are the same thing. Vectors are stuff you meet. Used to be on Leading Cert, and now it's only in university, but the idea is here, and we're bashing up against it right now. Okay, so you know straight away this is the vector from B to C. It's just instead of being the difference between a line segment and a vector is the vector has an arrow, it has a direction. There is a starting point and an end point, not just two end points. Okay, the image of AB under, okay, where's AB? This is our line segment. This is the image we're moving around. It's undergoing from B to C, so it's going straight down. The answer is DC after all that. The answer is DC segment. You cannot give DC as the answer because that doesn't mean that's an infinite line. The image of D, but you can move not a full line, but we were moving a line segment and we're creating a line segment. The image of D, the point D, under OB. Well, D under this goes to O. And the image of DC, where's DC? DC is the bottom, under vector from D to A, straight up. The answer is AB, line segment. Lovely. On we go. Okay, the video's getting a bit long. We'll just continue on with the homework now. Write down the coordinates of A, B, C, and D. What? It's so easy. Now look at how they did the scale like I did earlier in an earlier video. You just have to include. The origin is understood, so technically you wouldn't even have to write that that's not. So you have to put in your ones in order to say these are the scales. Like for example, this could have been a 2, and then this would be 4, 6, 8. Okay, just because you've grid boxes doesn't mean the scale is defined. So you'll often hear me just say, let's assume it's 1 to 1. So if I'm being a bit lazy and not putting down the scale. Okay, we're out 2. We're up 1, 2, 3, 4. And I presume this is going somewhere. This isn't just a first year maths level exercise. 3 minus 2. Okay, 2. By the way, you can put it anywhere around it. Okay, so like I can come here and say really big here. -2, -3 with a comma, and it's understood because it's the nearest depicted point that we're talking about. And we're back 1, 2, 3, 4, 5. And we're up 1. Okay, great. Each point is translated 5 units to the right and 2 units up. Okay, so that's a plus 5 plus 2. Okay, what are the coordinates of the, okay. A prime, I'm not going to plot it, I'm just going to say A prime is, well, I suppose they are asking me to do it physically, but adding 5 I get 7, adding 2 I get 6. I can do relative to this, 1, 2, 3, 4, 5, up 2. There's your A prime. Nice idea to put a circle around a point, by the way, especially when you're putting points all over the place and the examiner won't have a clue what you're talking about. Again, here we're going to go 1, 2, 3, 4, 5, and up 2. A nice idea there, guys, is to take your compass and open it out this amount, which would be, of course, the square root of 29, which is God knows what, but your compass will be open that much, and then you can just scoop across, and you'll see very quickly where the lattice point goes through. It's a very quick way of doing these. Okay, quicker than counting. You'll have D prime, here at 0, 3, and so on. That was a lovely question, wasn't it? Enough. Oh yeah, and then you're done. We're done. We only had up as far as question 9. Okay, as always, I'll see you in the next one.